I'm Dr. Frances Hawkes and I'm a Senior Research Fellow at the Natural Resources Institute, which is part of the University of Greenwich. So the aim of the project is to find some new ways of sampling neglected vectors, specifically blackflies and sandflies. What we're hoping to do is use some of the principles that we've applied in sampling mosquitoes, which we know quite a lot about for their behaviour. In this project we'll be using a host decoy trap that we've developed in partnership with Biogents. So the host decoy trap is based on exploiting the behaviours that we see in mosquitoes. They may apply to other vectors as well. The main principle is to mimic a host animal. And the way that we do that is incorporating three really important sensory stimuli that mosquitoes we know respond to. The first of those is odour. The second stimuli that we incorporated into the trap design that we know mosquitoes respond to is heat. So this thermal signature we've been able to mimic around 35 degrees. The final stimuli that we've incorporated is a visual stimuli. In that we mean something that's very high contrast against the background. We're really happy to be partnering with Dr. Rousseau-Jouaka, who works for the International Institute of Tropical Agriculture. So we'll be working with Rousseau in Cameroon to test the trap against blackfly. In that situation we'll be using a human landing catch as a standard that's used in many blood-sucking insect sampling programs, but we'll also be testing it against an Esperanza trap, which is an established blackfly sampling method for adult insects. For the second part of the project, we'll be testing the decoy trap against sandflies. So to do that, we're working with the International Centre for Diarrheal Disease Research in Bangladesh, and our partners there are Debashish Ghosh and Professor Dinesh Mondal. There we'll be using again the human landing catch as a standard comparator, so we can compare across the different case study sites. But we'll also be using a standard sampling method for sandflies, which is the CDC light trap. What we're hoping to achieve through this fieldwork is to either develop a completely new way of sampling these neglected vectors. That's really important because at the moment still there's quite a lot of reliance on human landing catches. They are quite ethically contentious, the idea of having somebody collecting potential vectors as they land on their own legs. Clearly we train people really well to avoid bites, but you can't completely stop that from happening. So having a passive system that doesn't involve any human exposure to infectious agents is ideal.